With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Question is, a body of mass m falls from a height h on a pan of negligible mass of spring balance as shown. The spring is ideal and has a spring constant k. Just after striking the pan, the body sticks with the pan and starts oscillatory motion in vertical direction. The velocity of the body at mean position will be. So here we can say we can apply here mechanical energy conservation at, let's say here we can say at this position, let's say this is the maximum compression position at which there is maximum compression in the spring, and this is here natural length position. So this one is natural length position. So applying mechanical energy conservation for system at these two position, at position A and this position here is maximum compression, at which we can say maximum compression here is, let's say y from this natural length. So this comes to be our as, let's say UA plus we have here as KA is equal to, we can say as UB plus we can say here as KB. So if we consider this as the reference level where potential energy is 0, so at point A potential energy will be our mg into, we have here as h plus y. Kinetic energy at point A is 0 as the body is released from rest. Now at point B potential energy, let's say due to gravitation, will be 0, and here let's say potential energy of spring here will be half of k into, we have here as y square, and kinetic energy as we know at, let's say maximum compression is 0. So this gives us as, we can say from here this comes to be our 2 mgh plus this here is our 2 mgy is equal to, we have here as k into y square. So this comes to be our ky square plus we can say here 2 mgy goes to right side, this goes to be minus 2 mgy minus here this is our 2 mgh is equal to 0. So this gives us y is equal to minus b plus minus we have here under root of b square, that is we can say here this comes to be our 4m square g square minus this comes our, let's say here 4ac. So 4ac gives us here as, let's say this comes as 4 into 2 mgh, that is 8 mgh into k as 8k we can say here mgh divided by 2a, that is we can say here as 2k. So on simplifying this, this comes as y is equal to here 2 mg and taking here 4 mg as, let's say outside. So this comes to be our as, we can say here as plus minus 2, and here we can say if we take m square g square outside, hence this comes as mg, and this part here comes to be our 1 plus, and this becomes our as, we can say 2k h divided by, we have here as mg divided by, in the denominator we have here as 2k, and we can say here equilibrium position, let's say equilibrium position for this, let's say here will be given here at that position where net force is balanced in this case. So at equilibrium position we can say, suppose this one here is our equilibrium position and this one here is our maximum compression. So first of all we find out, let's say maximum compression, we find out the amplitude to find the velocity at mean position or equilibrium position. So equilibrium position is suppose at y0. So at equilibrium position, we can say here spring force is acting, let's say here, in upward direction of magnitude here as k into y0 being balanced by its weight as mg. So here at equilibrium position we have here mg balancing k into y0. So we can say here this is mg is equal to, we have here as k into y0. So this comes as y0 is equal to, we have here as mg upon k. So the amplitude will be the distance from maximum compression to mean position, as let's say all distances are measured from, let's say, our equilibrium position. So this gives us amplitude as, we can say here, as our y minus, we have here as y0. So we can say this comes to be our, we can see here this is greater than mg by k. Y is greater than mg by k. So cancelling by 2 and taking here mg common, hence this comes as mg upon k, and this part here becomes as 1 plus, we can say here, for maximum, let's say, compression, this here is our 2kh divided by, we have here as mg. Now substituting the value to find the amplitude, hence this comes to be our mg upon k, and then this here is 1 plus, we have here as root under, we can say 1 plus 2kh divided by m into g, and minus of here y0 is mg upon k. So mg by k cancels out, and this simplifies here as, we can say as mg upon k under root of, we have here as 1 plus 2kh divided by, this here is our mg. Now velocity at the, let's say, mean position is maximum velocity. As we know, at mean position velocity is maximum given by our omega into a, where omega here can be said as our root under, we can say here as k upon m into, this here is our mg upon, we have here as k, and under root of, this here comes as 1 plus 2kh divided by, we have here as mg. So this simplifies here as, we can say this simplifies as root k by m goes inside this root. So this becomes our, let's say, this simplifies as root under, this here is our g square into m upon k into, we have here as 1 plus, this gives us 2kh divided by, this here is our mg. So we can say here this becomes equal to, on here opening the brackets, this part becomes our mg square upon k, plus this becomes equal to, k and k cancels, mg here cancels, so this becomes plus 2gh. So mg square by k plus 2gh is the velocity at the, let's say, mean position. So comparing 4 options, we have here option number 3 as the correct answer, that is root under mg square by k plus 2gh. Hence option number 3 is our answer.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.